Hi everyone, welcome to the Big Data Analytics and Data Science Interest Group. I'll be the weird guy who'll be talking to you over these screens, and just to make this a tad less awkward, I would like for us to play a little game that is universally known as the Let's Get to Know Each Other game. So I'll volunteer to go first. Hi again, my name is Piwe Twala. I'm a master's student at Wits doing research in cosmological simulations in the School of Physics. My research links directly to big data analytics and data science, in that for most of the data sets that I deal with, I need to mine out radio data to try and decipher what should we expect if we were to use the SKA low radio telescopes that are currently coming online. Now, typically, the size of the data sets that I normally look at roughly 2 terabytes. We will talk shortly as to why I might be incorrect in suggesting that because of the size of my data set, that my research project is a big data science research project. I'm also part of the Mathematical Sciences Support Unit, which is the unit that supports most of the research activity that's involved in the Mathematical Sciences School. Just in case you're wondering which schools are those, we're looking at your School of Computer Science and Applied Mathematics. We have mathematics, and we also have statistics and actuarial sciences. My interests vary across a variety of fields. So in short, I would say I'm interested in studying nature, looking at different puzzles, and gaining insight into new fields that leave me puzzled. So there you have it. That's what I do for fun. Now, to make this game an extra fun game and for me to actually get to know you, I would like you to send me an email to the given email address with your name, your research interest. Do feel free to also include your general interest as well. What do you do for fun? And most importantly, what would you like to actually gain from the time that you're investing into this interest group? If you can do that, that would be highly appreciated, because from our side and the team will actually be able to tailor this interest group to better suit all your needs. Moving on to the logistics of the group. Firstly, the purpose behind these interest groups is, or especially this one, is to introduce you to the basics for big data analytics, and to introduce you to simple concepts that I use in data science to mine out different data. Thus, the intended audience for these videos is anyone who's interested in data science or getting into big data analytics. We have no prerequisites, but as you would expect, having any background from the mathematical sciences puts you at a better footing. The way we'll run these sessions is as follows. I'll do a simple video, which will be similar to this one, and based on the feedback that I'll be getting from you guys, we will set up some time to actually meet and talk about the different concepts that we will be discussing in these videos. So the emails that I mentioned earlier on, they're quite important for this feature, so as to clarify what is happening and to help you move forward. Also, in total, we'll have 10 videos, and out of those 10 videos, 8 videos will be based on the methods that I used in data science, and then from that we'll be covering the basic theory behind those methods. In those videos, we will cover the basic theory behind the concepts and techniques that we'll be teaching you, and after you've gone through the different videos, you'll be big boys and girls in the big data science scene, hopefully. And after that initiation process, we have interesting projects that we, the mathematical sciences, would like to run. Thus, if you watch the videos and begin to think that, hey, maybe this material is too easy and boring, I'd say just wait. We do have a worthy challenge for you, you data maverick. Or if, on the other hand, you feel that what we're teaching is exciting and you would like to gain a deeper insight into the different techniques that we'll be teaching you, also we have projects for you. Now, in essence, we have different projects which vary in difficulty and interest. So whether you're a data maverick or someone who likes to get into the data scene, we have a project for you. Another addition that I should add is that these projects will typically be run over the December holiday. so that we don't interfere with your studies, as those come first in our eyes and always. I should note that it will be worth your while to stick around for the project, simply because you will be tested at a deeper level. The content that you learn from the different videos, plus you'll pick up meaningful programming skills from the languages that we'll be using. If you're interested in what sort of languages we'll be using Python, we'll be using R, and you'll also pick up some bash scripting. You also get introduced into the research environment that we have, which also includes the mathematical sciences high performance computing cluster, which has more than 2,000 cores, so you'll have more than enough ample time to play around with the different concepts that we have. So it's easy to see, if you stick around with us, you stand to gain a lot from the material that we will be offering in the interest group. But if, however, you're not actually interested in getting into the projects, that's cool with us. If you're just watching the videos to broaden your horizon and get new insight, we're totally cool with that. However, we would highly appreciate any input that you can give to us that will make the experience more pleasurable for you. Lastly, if you discover that data science and analytics is not for you, don't worry too much about it. We fully understand and we wish you well in all your interests. In the grander scheme of things, the main idea behind the interest group is that we want to introduce you, whilst you're still in the undergrad phase, to some of the research topics that our schools are actively involved in, with the hope that will spark some interest into going into that field. However, academia is not for everyone, so we will discuss how the tools that you'll pick up from this interest group will actually help you grow, not only in academia, but also in industry. Thus, the aim of the interest group is for you to enjoy the whole experience whilst you actually are growing. With that said, I think we've covered the basic logistics behind the interest group, and as I mentioned earlier on, feel free to send me any emails if you need any clarifications or you have any questions. Lastly, but never the least, we would like to thank our partner EMC and the Academic Alliance program, which we're part of. Most of the materials that we'll be covering is from their workshop that we went to, and we would like to thank them for their continued support. Now, enough about us and what we would like to achieve. Let's dive headfirst into the topic of interest. Everywhere you go nowadays, you hear the word big data thrown around a lot. I'm pretty certain that you've heard it before, and it might even be one of the main reasons that you've decided to join this interest group. In recent time, it's one of the fields that's seen a lot of investment drawn into it globally, and thus you have a lot of reviews that have gone into it, and most of the reviewers normally give it street cred, and thus making it very appealing to everyone. So you see such things as they are data scientists, the new rock star of the big data era, and those different phrases mainly stem from the fact that we are now in the Internet of Things, or as some people have nicely put it or phrased it, we are now in the big data era. What does that mean? Well, if you think about it, in the 1990s, you had companies like Oracle and SAP that were doing a lot of database management systems, which form the basis of what we now call SQL. A simple way to think about it is that these companies were providing data warehouses. You had a couple of servers, and their applications were heavily dependent on the hardware that they had, plus they had data that was homogeneous. If you fast forward to 10 years later, you begin to see what we call content and digital asset management system. Meaning, on a single server, i.e. your computer in this case, you now have multiple data generators that give you heterogeneous data. In this case, you now have Microsoft Outlook generating email data, you have Microsoft Word generating text data, you have Excel generating spreadsheet data, and you start to see PDFs popping up. These data sets are structured differently, but your local machine can easily compute what is necessary and give you back feedback. But we still are facing the issue that in this case, you're having that your different information or data sets are sort of resembling an island. So ideally, we would like an environment where there's ease of accessing to the different data sets and analytical tools. In this case, you should be thinking about skills that are required to run social media sites such as Facebook, WhatsApp, Instagram, and Twitter, just to name a few. Hence, for this case, I think it's clear to see that no single computer can actually compute all the requests that would be required by so many users at the same time over the internet. You now also include new phenomena such as cloud computing, and then you start having cases where traditional methods and old softwares begin to break because of scalability, amongst a host of issues which we will touch on later on. I think after that little discussion, you begin to see that there are new challenges around the big data era that cannot be solved using traditional methods and techniques. Thus, you have this popularity of the subject growing simply because it doesn't just affect the academic scene. These problems affect both public and private sectors. So whether you're in law, media, accounting, banking, policy making, or even the sciences, the need to get, process, and store data efficiently is of paramount importance, because whoever can manage their data in a more structured way that is transparent to analysis stand a chance to actually increase their productivity and value in their services. And in that, there lies the promise of big data science and analytics, in that it will allow you to unlock some potential that you haven't been able to unlock using conventional methods and softwares. Now back to us diving in headfirst into our topic of interest, which is big data. If we were to break down the words involved, you have fairly simple terms. You have big, which describes the size of what you're looking at, and you have data, which, as you might know, is information in raw or unorganized form, meaning it can be an arrangement of text, symbols, and numbers that has been collected for analysis. On a computational level, you would then take those different data structures, perform operations on them, and produce some sort of information which is useful, we hope. Without doing any searches online or from a book, if I was to ask you, what is big data? What makes data big data? What would you say? Feel free to pause the video and think about your answer. Also, try your best to arrive at some sort of an answer, because within the scientific method, your conclusions can be beautiful, but if the reason followed doesn't make any logical sense whatsoever, you'll have a lot of scientific scrutiny coming your way. So it would be to your benefit to start learning that critical thinking skill sooner than later. And just to give you a hint as to what to consider, ask yourself these following questions. Is there a threshold over which data becomes big data? How much does the complexity of its structure influences us to call it big data? How new are the analytical techniques used? As mentioned before, feel free to pause the video and think about your answer to the question. So let's answer the second question first. What makes data big data? Well, you have three main key characteristics of big data that make it big data, which are the data volume. As I mentioned earlier on, imagine the volume. In this case, you should imagine the volume that a social media site such as Facebook has to process every second from the individual users in terms of posts. Those posts can be in the form of text, audio, video, or the most likely scenario, which is a combination of those different data types. Add to that the requests from other computational processes that are required by the individual users. I hope you now begin to actually appreciate the science that goes behind you having your daily virtual interactions, or bringing your daily interactions over the internet. The second key characteristic is about the complexity involved in dealing with the data types and methods used in interacting with that data. Of unstructured data, we will explain shortly what unstructured data is. You find that 80 to 90% of the data that is in existence is unstructured data. What that means is you need to put in a lot of work into cleaning and organizing that data into a structured form that can easily be understood by the software you're using, or the framework that you're working under to compute any analysis that you would need. Thus, how you collect and input data into your models is of paramount importance. simply because if you collect your data in a structured and transparent way, you save a lot of time in whatever project you'll be involved in, because you'll gain a lot of computation, or you'll gain a lot of speed in terms of computational operation. Key characteristic of big data is the data structure involved. Data can come in multiple forms. Everything from highly structured financial data to text files to multimedia files and genetic mappings. High volume of data and variety creates the need for the preferred approach for processing big data, which is in parallel computing environments that involve massively parallel processing. This approach enables simultaneous parallel ingesting and loading of data, along with analysis from the individual computing nodes that are involved in the process. Now, how close are the two answers that we have? Just in case you're wondering what I'm talking about, remember I asked you to come up with your answer. How close are the answers that I gave you to the ones that you had in the beginning? If we match 110%, then congratulations to you for being on the big data ball. If our answers are diametrically opposed, then that's beautiful, because you stand a lot to gain from the upcoming videos. And lastly, if you're somewhere in between those two scenarios, then you're on the same boat that I was in when I first started. We touch on that comprehensive definition. Do note that the definition mostly speaks about the complexity involved in dealing with data rather than the size of the data. So when earlier on I told you that based on the size of my data, I'm dealing on a big data project, that's what I meant, that I might be incorrect in saying that, because it's not about the data size, it's actually about the complexities involved. And another reason that we might cite for not using data size as a measure for something being big data is Moore's law. Now, in simple terms, Moore's law states that every 18 months the processing power in your computer doubles. So if you had structured data in a table and that data followed a linear relationship in its order of complexity, then from Moore's law you would find that you would double your speed after 18 months. So if your data was structured and everything, in that case the size wouldn't really affect how everything works. The data explosion we're currently experiencing doesn't follow a linear relation. It actually follows an exponential relation. So looking at the size of the data set alone doesn't help us much with data science, but looking at the volume, the speed, the processing time required to perform and analyze data, along with the flexibility of analysis, has more meaning in data science. A little spoiler alert that I will throw in there is that, as you would expect, or maybe not, most of the data that we have is unstructured or quasi-structured in nature, which requires different tools and techniques to actually sort it out and make it into what you would generally love to use for analytics. With data structures, the more structured your data is, the more performance you stand to gain from your analytics. Structured data, which has well-defined data types, formats, and structure, is a direction that you would want to lean towards. As semi-structured data, as the name describes, it has some structure and pattern that you can easily see, but you need to pass it into some schema to fully unlock its potential. This is still in the realm of being easy in some ways. Structured data, on the other hand, has some patterns and recognizable structure, but you would need to first clean the data properly and develop some schema for you to analyze that data. Lastly, we have unstructured data, and as you'd expect, this is the most difficult data to deal with, in that you first need to clean the data, you need to put in a lot of work into actually organizing that data, and then after you've done all the cleaning, which is where most of the time you will be spending your time as a data scientist, you still then need to develop models and analysis that will help you to gain insight. So obviously, if I was to say to you something requires a lot of work, from my experience, what I've learned is a lot of people shut down. And in a similar way, if you need to put in a lot of work into your data cleaning and so on and so on, you taking time away from you doing actual meaningful science. So it is, as I did mention earlier on, it is very, very important that from the beginning you try to find schemas that allow you to save your data in a coherent way that will allow you to do analysis in a flexible. Looking at the different examples that we have for our data structures, in the first window you have structured data. As you can see, you can easily read it. You wouldn't need to put too much effort into cleaning it because it's already in columns. The format is uniform, and you can just do your analysis and your analytical modeling on it. Moving on to semi-structured data, that's stuff that looks like XML coding, where you can see the patterns, but then you still need the XML schema to actually get most out of it. An example of quasi-structured data would be your web click streams. Now, as a human being, if I was to just give you that URL, personally, I'd be seeing gibberish. But if you took the time to actually sit down and write down a simple algorithm that knows what to look at, it would know that certain features at certain points describe certain things that you would need to get to your URL. So that's a simple example of quasi-structured data. On to unstructured data, which is most of the data that we have over the internet. Now, it's not so easy to actually write up algorithms that will easily deal with pictures as they will with audio, or PDFs as they will with spreadsheets. This is where now you need to create new technical tools that will help you in your analytics. And this is where big data lies. Now, putting everything that we've learned thus far, the whole goal behind big data analytics and data science, which is what this interest group is about, is how do you firstly use what you have from the different sciences, mostly your mathematical sciences, to improve the insights that you can gain from your data. And building on that, how can you develop new tool sets and skills that will further enhance how you interact with your data and get the most out of your data mining? The hope is that once you've developed a scientifically structured method to deal with your problems, you would have then a way to actually get critique and improvements from your different collaborators or teams that you're dealing with. And most importantly, you would have a solution that works universally in whichever framework you're working under. Thus, the approaches that we implement try to maximize the speed of decision making of your algorithms, the throughput, which is how much are you able to put through your analysis, and the flexibility of your analysis. The hope is that you're moving away from having data warehouses or those, okay, firstly, you want to move away from the data islands, which are your computers, and then you want to move away from your data warehouses where you have all this information but it can't communicate with anything else, and you want to use something that's similar to a sandbox in that everything is actually in the same space, and to move from, you can easily move from one point to another, hence giving you an ease of analysis into your data. And once you have an ease of analysis into your data, you now have a analytical environment that helps you compared to people who are still using conventional methods. And in the current modern day big data era, the landscape isn't uniform, so you would try to develop tools that will make it uniform and how and deal with unstructured data that we. So what are the benefits of going into data analysis? Well, firstly, it's employability. If you actually take some time to Google different jobs that require data science, the amount of companies that are requiring data scientists are growing at a crazy rate, especially in SA as well. But beyond just looking for a job, you have different fields that would require your skills. In essence, any field that is data driven, you can go into. So the list is on your screen. You have your academic institutions, simply because you do need to analyze your data afterwards. So, from the different experiments, what's the best way to go about cleaning that data and getting the most out of it? That's something you can think about. You can go into the medical profession in that you have your MRI pictures. For just as an example, how would you develop an algorithm that can take different images and identify what features are on there, and help and B, a tool that helps doctors to better diagnose patients. The internet, as we've mentioned before, is totally unstructured data. So if you have insight into how to do data analytics, you can get the most out of the internet. And in a reversed way, a lot of people get a lot of data from you, and they mine a lot of data from the internet that you are producing. So they also need tools that will help them analyze your activity and what sort of behaviors do you get up to, so that they can gain the most from that. You also have your financial sector. So with all the transactions that are going on in different banks and retail places, how do you go about keeping track of all those transactions? And beyond that, how do you better offer a service that will enable you to maximize the value of your company? So another a simple example that's often used is if you look at companies like Amazon. They've developed amazing tools that track your different web click streams. So they keep track of, if someone buys an iPad, they have a chance of buying a microphone or a stand or a case. So every time you click on the iPad, you'll get suggestions, and that actually it helps someone. So can help you get the most of what you want, and it also helps the suppliers to tailor different solutions for you. And in a similar way with mobile devices, you also need to come up with techniques that will help you sift through all the data that you're constantly pumping out from the different mobile devices, and there's a plethora of those. Now, moving on to the government. If you are the government, you have a lot of policy making that you need to do, and you also have the issue of so say you wanted to distribute condoms. How would you go about that? So of course you would need to consider a lot of factors, and then from those factors you draw up a model, and in that process you'd need to acquire your data, clean that data, and come up with models that will help you better distribute those condoms. Be warned though, because an increase in data doesn't mean a decrease in complexity. So we will, as we're moving forward, also point out the low hiccups that you might encounter. But when you're going through everything, do consider what you're doing critically, as I did mention earlier. Okay, in summation, our mission is to introduce you to big data analytics and data science concepts that you can start playing around with in undergrad, and hopefully by the time you get to postgrad, you would be able to now fully unlock your skills and your potential without needing to learn the basics. If you're not interested in academia, the different techniques that we'll be speaking about, they actually form the basis that you would need to go into industry. So going into the work environment and they doing data analytics and data science, you wouldn't need to first discover what are they even talking about. After going through everything that we've gone through, you should be able to give a clear definition of what big data is about, and give the 3 key characteristics that make big data big, which we spoke about earlier on. Lastly, you should be able to talk about the different data structures that are involved in manipulating data, so that you don't find yourself going blindly into a very dangerous and tricky situation. Now, there were a lot of concepts that were mentioned during this video. If you somehow got lost or you are not getting the concept, it's not a train smash. Do rewind. If not, do take some time to actually look up some of the concepts on the internet, because as we've mentioned, this is more of an interest group and it is to spark your interest. So don't be afraid to supplement the information that you're getting. And most importantly, don't forget that I'm part of that supplementary package. So if there's any points that you missed or you don't understand, feel free to drop me an email. I'm more than willing to help you better understand what's happening. Do join us for our next video, which will mainly be about the data analytics life cycle and the methods used. See you then.